Harish, in the interest of time, if you could just kindly start the discussion.
Sure. Simon sir, can we go ahead and start it?
Yes, sir. Yes, sir. You can start.
All right, sir. Thank you so much. Thank you very much. Thank you to all the faculty members who have attending the meeting today. All right. A very warm welcome to everyone. My name is Harish Murthy, and I'm from the customer success team at Mathworks. Along with me today, I have Janardhan from Mathworks. He's the account manager. I have Anand from the customer success engineering team, and I have Zafar from the design tech systems, and Zafar is a senior manager. Right. So we are going to go ahead and start off with the session now. All right. So before Anand starts off with the day one session, I'm just going to go ahead and present about the campus-wide license, which I'm not going to take more than 5 minutes. And I would be talking about the Matlab portal created for Hindustan Institute of Technology and Science. And also we have muted everyone in this meeting today just to ensure that we have a better audio quality. In case if anyone is having any questions or challenges, please post in your questions in the WebEx chat window so my team here can address your questions and address them. And Anand, is my screen visible?
Yes, Harish, I can see your screen. Yeah.
All right. And is the recording started?
Yeah, I've started the recording.
All right. Thank you. All right. So before I start off, I just wanted to introduce the account team. So from the Hindustan, we have Dr. Simon sir, and from Mathworks team, as I mentioned, the entire account team is here. So at any point of time, in case if anyone is having any challenges, you may reach out to Simon sir, or also you may reach out to us. I will be sharing the contact details of our team, and any questions or concerns in terms of the toolboxes or installation, you may always reach out to us. And talking about the campus-wide license, what comes with the license is this is the annual license. It is available for all the faculty members, students, and the research scholars in the Hindustan Institute. And the access to the license is just not limited for classrooms or labs alone. You can access the license from anywhere, that is from your home, or in case if you are presenting in a different institute, you can access it from anywhere. And also, the installation of the Matlab and the toolboxes can be done on both the institute provided laptops as well as your personal computers. All right. And apart from this, what comes with the campus-wide license are, first thing here is the Matlab Online and the Matlab Mobile, wherein in case if you are having any challenges installing the Matlab software in your computer because of the system requirements, you may also use the browser version. Though you would not have all the features and there would be a few limitations, I will be sharing those limitations as what they are. So this comes with a campus-wide license, and you do have the Matlab online training courses, which is available for, once again, for all the faculty members, students, and the researchers in the institute. So along with the free on-ramp courses, you would also be getting the premium courses, and these are self-paced training courses where you can complete the courses at your own pace. And also you would be getting a course completion certificate upon completion of each course. And also, for all the faculties, we do have the Matlab Grader, where you can go ahead and upload your assignments to the students and they would be auto-graded. And we can also go ahead and have this implemented the same in the internal LMS system. So for all the faculties who are interested in knowing how the grader works, we do have a grader workshop at the on the third week of the webinar series. So please do register so you can know more about the Matlab Grader. And yeah, so these are so as I mentioned about the online training courses, these are the list of courses that is available with the license. So apart from getting started with the free on-ramp courses, you do have access to all the premium courses, that is the data science, core MATLAB, and computational mathematics. So I will be sharing all the links on how to access these courses and what comes with the course after my presentation in the WebEx chat window. And as I spoke about the Matlab Grader, I wouldn't want to take a lot of time here because Anand would be talking about this in his coming presentation. And as I also mentioned, we do have a different session for the same. All right. The main thing what I wanted to talk about today is the Matlab portal that is created for Hindustan Institute of Technology and Science. So this portal is completely managed by Mathworks. The reason why we have created this portal is, as this is a campus-wide license, we wanted to ensure that all the faculty members, students, and the researchers in the institute have access to the campus-wide license, so they can go ahead and continue working on the Matlab and the toolboxes. So you do not have to go to the IT or the concerned point of contact every time to gain access to the license. It is very simple. If you have an institute provided email address from Hindustan Institute, you can directly go to the Matlab portal and have an account created. It is a compliance built portal, so you will not be able to have an account created with your personal email. It has to be the institute provided email. And also this portal has all the information available on how to contact the IT support, how to access the Matlab online, the online training courses, the grader, everything is available here. Um, so what I'll do is quickly let me go ahead and share a live portal demonstration. And while I'm sharing this, in case if anyone has not created a Mathworks account, you can also try creating a Mathworks account with the institute provided email address. So I'm just going ahead and sharing the Matlab portal link once again in the WebEx chat window. All right. So this is the live portal demonstration, and this is the live portal which is created for the institute. All right. And to in case if you already have an account, you can just click on sign in to get started. All right. Or in case if you do not have one, you can just click there and click on create one, where you can enter the institute provided email address and then enter your personal information and have an account created. And also here where you see the list of available products. These are the toolboxes available with the campus-wide license. And in case if you want to know more about these toolboxes, you can just click on these toolboxes. It gives you a brief description on what this toolbox is all about, so you can get more information. And yeah, as I told you, once you log in, you can go ahead and access the online training courses. You can access the tutorials, all right, and also the Matlab Grader and teaching with Matlab. And in case if you are having any issues in installing or having an account created, you can just click on need installation help. Here we do have a couple of videos which talks about, once again, account creation, installation of the Matlab and the toolboxes. And at the bottom, you can just scroll down and to show you here contact support. Once you click here, you can either raise a service request, or you may also reach out to the installation and the licensing team on this number, so we can have your issues addressed in a timely manner. And that brings to the end of my presentation. All right. I don't want to take too much of time. So before Anand starts off with the actual presentation for the day, please let me know if anyone has any questions, or what I can do is I can also make Anand wait for a couple of minutes if anyone wants to try and create a Mathworks account by accessing the portal. Anand, let's just wait for 2 minutes, post which you can go ahead and
Sure,
start
Harish.
the session for the day. Thank you so much.
So Harish, I see one question in the chat. So whether we need to go to the HIT's website to start with the email ID. So Harish, if you are speaking, you are on mute.
Yeah, I'm here.
Okay.
I'm sorry for that.
Yeah.
All right. It looks like whether we need to go to the Hindustan website to start with our email ID. All right. Sir, to answer to your question, Ravi sir, you just need to go to the Matlab portal link that I've just shared in the chat window to have a Mathworks account created. Yeah. The Matlab portal link is once again shared by Anand. All right. So let Anand start off the session, and you can try creating the Mathworks account in the meanwhile. I'm going to be here in this meeting. So in case if you have any challenges, you can let me know, or you may also directly send an email to info@mathworks.in in case if you are having any issues in creating a Mathworks account or having the Matlab software installed in the computer.
Okay, thank you, Harish. So, Harish, can you make me that presenter?
Yeah, sure, Anand. I'm going to do that right away. All right, Anand, you're the presenter now for the meeting. Thank you.
Thank you. So let me know if my screen is visible.
Yes, Anand.
Okay. So thank you, Harish, and thank you, Professor Simon, for organizing this. So Harish already gave an introduction about us who are present today. So we also have Zafar from the Design Tech team. So he would be taking the next session, and we would be doing this together over the span of 5 weeks. And in this call, we do not have Shovik, but he will be joining in the upcoming session too. And we are from the education team at Mathworks. So we work with the universities, with faculties and institutes across India to help them support in their curriculum and research activities. And this is the poster which I think you must have already seen. So this is week 1, and day 1 we will be covering the overview on modern Matlab, the different features, whichever are the latest one are available and which you can make use of in your teaching as well as research. And in day 2, we would be covering some basic fundamentals of Matlab, how to do some basic operations. And similarly, the other weeks are also planned. And yeah, now coming to today's agenda. So
Anand,
yeah.
Anand, sorry to interrupt you. Before you start off, could you please go to the for all the sessions that we're going to have for the next 4 weeks, all right. So the link to go ahead and register would be the same link, that is Mathworks events, all right. So under this link, once you go to this program, you would see the list of sessions for week 1, week 2, week 3, week 4, week 5. All right. So as of now, you would be seeing the sessions only for week 1. All right. But we will be updating the schedule and the meeting links for the upcoming weeks. So please use the same link. So in case if you have any questions, you may reach out to us. But that is going to be the link for the next 5 weeks. All right. Thank you.
Thank you, Harish. So yeah. So coming to today's agenda, we will give a brief introduction about what Matlab and Simulink is, and what is experiential learning, and what is the importance of computational thinking in teaching. Then we will go and show you some demos related to live script, how you can make use of it, how you can use apps, existing apps, as well as make apps from the App Designer tab. And at the end, we will conclude by letting you know about 5 things that you should know about modern Matlab, and the resources, there are multiple resources to get started, how you can get started. And also you can type your questions throughout the session, so we will try to address some of them in between as well, and we will take your feedback at the end. So let me see the chat window. I can see one question. Full features is available in the Matlab Online version as well as the installed software. So thank you for asking that. So good to know that you're aware of the Matlab Online feature as well. But we do not have all the features available in Matlab Online, but most of the things are there. So if you want to get started or do some basic computation or basic work, even if there are some apps which you can make use of, but in case you want to use some specific apps which particularly fall under certain categories, then I would prefer you to install the Matlab desktop version. to get all the access to all the features which are available. So that is okay. I see my voice is breaking. Okay, let me check. So, am I audible now?
For me, you are absolutely clear.
Yes,
Anand.
yes.
Okay, thank you, thank you. Okay, so I just adjusted the microphone of my mic. So thank you for telling that at the beginning. Yeah, otherwise at the end it would become difficult. Yeah, so you can type your queries in the chat window. I will try to look into them as well. Now, just a couple of poll questions before we start, just to since all of your faculty members here, just I wanted to know, have you used MATLAB before? You can just type a Y or a N. So in case you haven't used, you can type N. Okay, sure. I see 2NY and I see N. Okay. So there is a mixed kind of response. I see yeses, I see no's as well. I see no Xilinx. Okay, thank you for mentioning that. So uh, yeah, so there are some features, HDL related features which can be covered using MATLAB as well. If you have Xilinx installed, it is good to know, but you can do those auto code generation thing also. So we can get in touch with you along that line also. But I see, oh yes, 12 years. So thanks. It is very good to know. 15 years. So that's a lot of time. So yeah, so it's kind of a mixed audience. So we have 15 years experience who have used MATLAB. We have beginner audience as well. Okay, so I got an understanding of this. Just a follow-up question, because but this will be relevant to those who have used MATLAB. That have you used Simulink in the past? Because Simulink is a part of MATLAB. So for the second question, I again see yes and 2 years. No, yes. Okay, so here we have again here I see more nodes in the case of Simulink. Okay, sure. So in week 5 we will be covering on Simulink, and we will try to showcase a brief example of Simulink today as well, just to show what it is. Okay, thank you for your responses. I got a fair bit of idea, and so let's get started. So MATLAB is the full form of MATLAB is Matrix Laboratory. So here basically we deal with different computation involving matrices. So for example, we can define, we have some user or library functions available like square root, which can compute the square root of numbers. We can store numbers in the form of matrices, and we can solve different mathematical operations to achieve our task. Okay, so it is great for solving matrix problems, and almost all mathematical problems related to engineering and science could be will be in the form of matrices. So it is great for engineering and science applications. So that is the reason, and very easily with couple of lines of code you can plot what you want to plot the data. For example, here you can see the x-axis is time, the y-axis is the magnitude of the sine wave, and with these two lines we are just plotting x comma y, and here is the plot. So we can visualize the data very easily. So this is one basic way. And we are from the customer success engineering team. So I already said before how we work. So we work with the faculty and researchers to support them with their STEM initiative. So this includes to include computational thinking in their curriculum as well. So not only research, but throughout their teaching journey, if you can, if the PowerPoint or meeting recording will be shared offline. Yeah, yeah, we will be sharing the recording. It is being recorded. I'm from biological background, microbiology major. Yes, so this will be useful for you. So even in different science disciplines. So there are experiments labs. So in which I believe there must be some kind of data analysis or things to do with computation. So if it is there, then this will be surely be applicable to you as well. We will show you the resources actually which relate to this thing. So yeah, so let's see. Yeah, we would be sharing the slide deck as well as the recording. So thanks for asking. Yeah, so uh, from the industry perspective, so these are some of our customers in different domains. So you can see aerospace and defense at the start, then automotive, which are two major players. Apart from that, we also have applicability in other industries related to biological science, biotech, communications, finance, energy production. So it's almost spread everywhere. So in any industry, wherever there is a need for computation or to do certain computational tasks, so they use our tools to achieve those uh, in a timely manner. So the main idea is to uh, complete the project within time. So that is one of the reasons. And these are the different domains in which we have our tools, as well as we also work with third-party tools also. If we do not have the tool directly, we can install it in through the add-on browser. Right from deep learning to robotics, from wireless to computer vision, and so on. Even if you're working on Internet of Things, so for example, there is a ThinkSpeak platform which you can make use of to do IoT related applications. So yeah, so Mathworks has two products. So first is Matlab, which you have just heard of, and also there are a few users who have used Simulink, but those who are not aware of it. So just to reiterate, so Matlab is a technical computing environment, which is where you can write your codes and where you can make use of certain apps to do some computational work. And Simulink is a part of Matlab where you can do basically modeling of different systems. So here you have to make block diagrams of your system, block level diagrams, as shown in the bottom corner. And with that, you have to complete your maker system, and you can test the system in the simulation environment prior to deployment. So this is one thing which is very much used in automobile sector, because prior to manufacturing of the automobile products, so I mean the rigorous process of testing has to be done, because this is quite expensive industry. So if there is some test error at a later stage, there will be huge loss. So that is why Simulink is used extensively there, where the controllers, the design of the controllers of these vehicles or any other part which needs computation is thoroughly assessed and prior to deployment. So it is kind of a model-based environment where you can make models. And whereas before that, you can see on the top right, there are some examples of example windows of Matlab where you are seeing some live script and some app kind of. So on the right, this is a kind of app which is giving you a certain uh, with which you are doing some kind of analysis. So this is just an overview. We will start with some simple examples. And this is one example of another user story related to industry. So here we see Aether Energy, which develops electrical two-wheel scooter and charging stations using model-based design. So whenever you see this term model-based design, you will be able to understand that they have designed it using the Simulink environment. And the challenge here was to design and produce India's first intelligent electric scooter. So this is a very demanding market. Lot of startups are there in these fields related to electric automobile uh, and throughout the globe. So Tesla, like Tesla by Elon Musk. So you must all have heard of that. So this is a very emerging area where the solution here was to simulate and optimize the scooter design and to generate a production code for its control software. So that's it. So first of all simulating the design of the scooter in the computational tool, and once that is done, the code can be auto generated. So that is another great feature of Matlab. The code which has to be deployed to the control software, the processor or any other target hardware, can be deployed once the MBD design is made, and it could be used for production. So because of this code generation facility, the testing time is reduced significantly by 50%, and that is why the design can be evaluated very easily, and the prototype can be made. So this is one example of industry. And now from the education perspective, so why we should how rather than why, how we should use Matlab in the education domain. So in this graph, this is taken from AICT website. We see four blocks. So the first block, which is orange in color, is the intake capacity of different colleges and institutes for the year 18-19. Okay, and the enrollment is almost half of it. Okay, so 50% of students enroll in those colleges, and around 80% of that is around that number. Students are actually are able to pass the course, the 4-year course, UG course. And with regards to placement, it is again half of it, or somewhere near half, till 2017-18. And yeah, so I think there is some mismatch in this section. So this so no worries, but so this is the usual trend here. And our idea is to find the reason why. So the reason here is that in industry, in different industry, wherever who are recruiting students, so they try to search for students who have certain specific skills related to computation. So that will help them save time in terms of training them. So if we can train those students along those lines during the span of 4 years, then it would be very beneficial from an overall perspective, from the industry academia ecosystem perspective. So here we see like in research universities, computation is required. So whoever is doing research, so they will know they need to accomplish certain tasks or projects. So for which they will require certain sets of tools depending on the on the discipline, and it is related to solving those problems using computation. Similarly, in industry also, it is heavily relied on different tools which are capable of doing certain computation to help them design their prototype and manufacture their product in a specific period of time. Now here comes the UG education. So if we can train the UG students during their 4 years course, or if for a MTech during the 2-year course, then they can go in either direction. So they can go to the industry as a skilled workforce, or they can do further studies and get started with doing research, and save a lot of time. I mean, very quickly the transition will be smooth because they are already aware of those computational tools which are used during the research work. So this is the main idea, to educate the workforce right from this level, so that the transition to both places, to research universities as well as industry, is smooth. Now, so in this slide, so we see a teacher is teaching and explaining some important concepts, and here it is written, "Trust me, this is very important." And here a student is looking at the back and thinking, will I ever need to know this? So maybe the student is not understanding or not following the class, and just not able to relate why we are learning so much of theory without much understanding. So this is a very common scenario. So when in every subject, uh, if a student is not attentive on all the classes, or student may get bored also after listening to all the theoretical stuff for a lot of time. So the idea is here that if we can introduce some computational part within different courses, then this kind of problem can be avoided. So in that case, the student will be interested and would be able to relate certain theory with practical, right? So that is why we also have labs for certain courses, theory courses. But even for the courses where we do not have lab, we can give some kind of computational assignments to the students to keep them engaged. And this graph just shows the learning curve of the student. So when we do not give that computational learning to the student, then this is the graph. And if the student is able to make use of those computational learning in the form of projects or to do some practical work from the theory, then the learning is enhanced, and hence this curve is a bit steep compared to this one, and it is easier for the student to reach at this point because of this learning nature, rather than the other curve, yeah, where the student has to do a lot of thing at the end to reach to the same point. So how is computational thinking important? So here we see a quote from Steve Jobs, like that coding teaches you how to think, so which is true. So we have to learn to code first of all, and once we know some coding, we have to code to learn, because we are not learning to code just for the sake of it. So we want to learn code so that we can apply it somewhere. So where should we apply it? So that is what is code to learn. And when we join this together, then this computational thinking framework is formed. So we need both the pieces here. So here we see another quote by Trinity School High student, like coding teaches me to think in a logical way, which is true. So once you know a certain form of code, then you can think in a logical way, because these are logical statements, and you have to map those to the different applications or the different areas you are working on. Now, so how can we teach computational thinking? So this is the challenge. So do students just pick up computational thinking by themselves, or means during the course, during the course of time for a UG course? So I just want to know your idea. Means anyone, you can just we can have an interactive discussion also, if you can unmute yourself, or if you can type it in the chat window. So what do you think? Do students just pick up computational thinking, or how do we ensure that? Okay, I see one answer. Thank you, Professor Parvati. It has to be trained gradually. That is a very true answer. It has to be trained gradually, right? So that is the on spot answer. So very correct. So it has to be trained because suddenly the student cannot means in a day's span of time cannot just think computationally. It has to be trained gradually throughout the course, throughout the different courses, so that at the time of final year, or at the time when the student is doing their project work, they can think better in terms of solving those projects, because they had done this kind of thinking earlier in bits and pieces during the different courses. Now, if we compare the same thing with the mathematics skills that the students are uh, learning during a UG course, so it is quite similar. So mathematics is taught systematically and reinforced throughout the curriculum. So for any engineering course or any science course, so mathematics is the foundation. It's a foundational course. So every first year student or first and second year student, there will be some dedicated mathematics courses where the students learn different important concepts or important aspects of mathematics, which they can relate later to the other subjects, other engineering and science subjects at a later stage. So in a similar fashion, if we can introduce computational thinking at an early stage, right, starting from first year, okay, then the students will slowly develop the ability of computational thinking, which will help them at a later stage. So that is the basic idea here. So thank you, Professor, for the comments. So that's absolutely true. Now, looking at the math curriculum, so it's a general curriculum. It may be some of the subjects may be in second year in terms in place of third year, but in general, the core mathematics courses, which are the dark blue ones, are calculus 1, calculus 2, or linear algebra, differential equations, numerical methods, or there are so these are the core things which are taught during first year, second year, or maybe third year also. And the courses which apply mathematics are the other courses which are shaded in light blue. And this is, for this case, this is the curve in which the student uh, cumulative learning proficiency increases. Okay, so it increases till this point. Whenever after these courses, after second year, it goes here, and slowly, gradually, it increases the math proficiency, because they are applying the maths in the different engineering subjects as well. Similarly, if we try to map it based on computation, then these are the computational courses like programming numerical methods, and like programming numerical methods, and the other courses again require computation in some form or the other. So with this trend, the students' cumulative computational proficiency graph looks like this, and the idea is to utilize both mathematics as well as computation for these courses. So learning to code in these subjects, and coding to learn in the other ones. So once the student knows some form of coding, they can use those in the other subjects to learn do certain computation which is related to those subjects, applications related to the syllabus which is taught to the theory. Then this will help in a similar way to help in a similar way. I mean that at the final year, when the student will be doing the project work, then the student will not only have a strong mathematical background, but also have a strong computational thinking ability. So with this, the student will be able to do better projects, and also it will be good from an overall perspective. Now I would, it's right now, okay, I will take some more time in the slide window, then I will just go to the demos which I want to show today. So before I go there, again, I just want to discuss a few aspects like the pedagogical goals and challenges that an instructor faces usually. So, so initially, whenever a course is taught, so it is mainly maybe it is taught using pen and paper, and after that, we need to engage the student in the classroom, and finally we want to assess the students and get give them their feedback, how what they have learned. So here in the first stage, if we can prepare the students, so during the course, so if I go back again, so during the course, if we can introduce some kind of computational uh, what do I say, computational methods to teach for that particular course, then it will be helpful in terms of student engagement. The student will try to understand the theory and practical better. And finally, what are the tools which can be used to assess the student? So we will be discussing on those also, and what are the resources which can get you started with this workflow. So this is the overall idea, and we have quite a few resources which will help in all these three aspects. So we will be discussing that in today's session. And now let me go to the Matlab window. So this is demo one. So we will be showing you a live script. So those who are aware of it is good, but those who are not aware of live script, so they will come to know what is live script. And we will be creating a sine wave and show you how you can make use of live script for that. So this is the Matlab window. Let me just resize it. And yeah. So I hope the screen is okay. Everyone can see can read the font size here. So you can just type Y or N. Okay, I see Y. Yeah, thank you, sir. Thank you. So I think this is okay. So live script is nothing. So if you are new to Matlab, so or okay, I will share those resources at the end. But those of you who have used Matlab may know of .m file. So if you start a new script, you can easily write some comments on the with this section. You can create section breaks by this double comments, and you can define variables. So for example, if I write t equals to, or if I write a equals to 1, so this is a variable which will be created. Or if I want to write an array 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and I can just right click here and evaluate the current section. Then I will be able to see the variables in the workspace, which was empty earlier. So like we have two variables, one is a, another is array, and we can look into it, how that variable looks like by double clicking in it. So this is the normal script, but a live script has by using live script, so you have to choose the second option. If you choose a live script, your a .mlx file will open up, and here you can do multiple things. So you can insert text, you can write. So if I insert text, you can write, for example, the title of the project or title of the course. Okay, then maybe you can write some code here within this shaded. Okay, once again, tell how to open. Okay, yeah, thank you for asking. Okay, so this is the Matlab window where we have this home tab, and this second tab is known as new live script. So if I click here, so it will open up in the editor window. So this is known as the editor window, and we have this live script opened up here. So here we can write text as we are writing here. We can write code, and we can also see the output of the code here. Okay. So for example, one live script is, I've already created a live script here where the title is mentioned here on the top, and what we are trying to do is written here. So we want to plot a sine wave, so which creates a sine wave with the following parameters like amplitude, frequency, and phase. And this is an image which we can also include images. We can include hyperlinks if we are taking the image from some reference, and we can write equations as well. So this is nothing but just a kind of documentation till now. We have not written any lines of code, but suppose we want to continue this live script further, then we can just click on the code section here, and we will get this gray shaded box, right? So for before writing any code, the best thing to do is to clear all the variables. So if we write clear or C and CLC, so this is good to get clear the variables. And I'm running the section. So let me Yeah, I want to move this. But yeah, yeah. So sorry for that. I wanted to move that. It was again. It came. Okay. Yeah, sure. Yeah. So with this, I can create a section break. So I can create multiple sections. So if I want to run the first section, so only by clicking here, we see the workspace was had two variables earlier. It is cleared out now, and we can continue with the next section, right? So in the next section, suppose we want to plot this kind of sine wave, then what to do? Then we will be need to define the x-axis, so which is the time axis. So for that, we would make a vector which can be made with this command. There are multiple ways to do that. So this is just one way. So from 0 to 1, if we want some 1,000 or 10,000 points, vector will be created. So I'm just running this just to show you parallelly. So here we have a vector of 10,000 variables, which is created with an equal step size. Okay, so we can just have a quick look into the plot window as well, just to visualize. Yeah, so this is a linear plot. From the diagonal it is going. So the increment is constant. With the equal slope, we are increasing the thing. So we have verified it. This command works perfectly. Then we can define the other parameters. So maybe the amplitude of the signal. So if it is maybe 5, I'm not mentioning any units as of now. So you can assume it is volts. And for the frequency, we can type maybe 2, 2 hertz. And for the phase theta, so I'm not giving any phase as of now. So I've defined the parameters. So the parameters which are mentioned in this equation. So we have defined the time vector, we have defined the amplitude, we have defined the frequency and theta. And 2 pi is a constant. So we don't want to define that. This is already available uh, in the background. So we can now define the final function. So we want to define the sine wave. So if we write a equals y equals to a multiplied by sine 2 into pi to ft plus theta. So with this, we have defined this simple function of a sine wave, and we see we have all the variables, whatever 5 variables we defined. So all of them are in the workspace. We can look into it and plot it as well. So like if we want to plot without writing any code, we can do that by clicking on the x and y axis, going to this plot bar, clicking on plot, and we will be able to see this sine wave right here. Or else if we want to just write the plot commands using sine wave, so in that case we can again uh, go to the live script, and maybe since we are kind of doing it, we want to document this, because the same thing can be written in the command window itself, command window as well, just to for the sake of programming. But if we want to document some kind of concept that we want to teach to the students, so that is why we use live script, so that the students can read it and also code it and also see the output at the end. So that is the reason we are doing here. So suppose I am writing plotting uh, sine wave, and I can maybe type it as a heading 2 and make another section break. And here I can just simply write the plot command, which is a straightforward command to plot the variables. And we can give some labels also, so like the time axis, and amplitude. We can also give a title to the plot. So suppose we want to sine wave. Yeah, so I'm running this. So where is the plot? Here is the plot. So see, so when we write this plot command, so instead of a separate window, we see the output in the same live script. So we can hide the code also with this command, and we can also see the output in two different ways. We can see it sideways, or we can see it at the bottom of the code. In this case, at the bottom of the code, this got executed, and we are able to see this sine wave. Okay. So now another good feature about this live script is that, so there are some. Okay, yeah, okay, thank you that. So I hope I'm not too fast. Okay, I will try to go a bit slow. So now, so inside this live editor, we are using all these different commands to do to make our live script interactive. Oh, that's a very nice question. Where is the run command? So I ran a couple of sections, but I didn't use the run command. Okay, I was using this blue strip at the, which you can, this is highlighted here. So whenever I run this, it will run the first section. So just to give a brief recap, it cleared all the variables. Then if I run the second section, okay, it ran the second section. Instead of that, I can also use the run command. So this will run the entire script. Okay. Or if I can run this a particular section by running this script. So let me do this for the next one. So instead of using this blue tab, left tab, I want to run this particular section. So I am in this section, the section is selected, and I'm running the section. So I am able to see this. So in case you want to just clear all the output, I do not have the output. So this section is not yet run. So let me run it again. So yeah, so there are multiple ways we can run it. We can also use this command, or we can use this command. So both ways it is fine. So another thing is the good feature in LiveScript that you should be aware of is this panel, the insert panel. So here you can actually change, use multiple interactive tools like the slider. So the numeric slider, if I give a numeric slider from 0 to 20 maybe with a step size of 1, then it means that it will vary from 0 to 20 with an increment of 1. And we can choose certain options like value changing or value changed. So whenever the value is changing, it will make effect on that particular section. That is what it is meaning. Or if you want to, the other option, after the value is changed, then it should run. So let it keep it as it is. And so now we have this thing. So we can increase the, let me show it side by side. Yeah. So I'm changing it, the frequency, but this section is getting executed whenever I change this, because so if I want to merge this with the earlier section, I just delete that section break. So this is now the same section. So now whenever I change the frequency, so based on the frequency, if frequency is 1, I can see one waveform. If it is 2, I see a couple of them. So like that, we can do a kind of make use of these sliders as well. So that is another thing. And next is this taskbar. Just after this controls tab. Okay, how do I merge? Okay, so yeah, that's a good question. So this is the section break which I was using. So if I create section break, so I have a new section. And if I want to delete, I just click the backspace button. So that section break is gone. So that's it. So this is the section break, and this is the back button to delete that section. So this is how the sections got merged. And yeah, so and next what we will do is that, yeah, the another thing, the live task. So within the live script, so this is the live script. So within the live script, you can use live tasks as well. So here you can go to the how to add slider. Okay, so there are okay, let me just give a brief. Let me go a bit slowly. I guess there are a couple of questions coming up. So like, this is the home tab, this is the plots tab, this is the apps tab. Similarly, we will have this live editor and insert tab whenever we have this live script opened up. So this is the live script, and from this insert tab, we have multiple options. So within this control, we chose this numeric slider option. Okay, so even if you are trying to do the hands-on right now, it is good, but I will share whatever we are covering today so that you can revisit it in your own time as well, and it would be helpful. Okay, so in case you are not able to follow. Oh yeah, this is actually zero. So if you are, I got a question from here. It is zero, and so yeah. So thank you for asking the questions. So that is great that you are having so many questions, so which are very relevant. But another important thing is feature which is actually helping you do a lot of computation is this live task feature. So within this task, you can choose multiple things. One of which is, maybe let's choose this find local extrema one. So if I choose this here, then this kind of window opens up within the live script. So this is a live task, and let me just show you how to use it. So here we have to provide the input data. So here the input data is, suppose, the y-axis, and the x-axis is the time axis. Okay, and that's it. So if the extrema type is maxima, it will just detect the maxima, the peaks within the signal, and it will give the count. Similarly, if I want to calculate both, maxima and minima, I choose the other option, and I am able to see all the maxima and minima plotted here. The figure can be exported also, or it can be opened in a new window as well if you want to somehow save it or do other things. But the idea is that within the live script, you can count the number of maxima minima with this by running this live task. Okay, and the code behind it is shown below. So if you just open this live task, you will be able to see what are the different codes which helped us achieve this thing, in counting the functions used to count the maxima minima and plotting this thing. Okay, so similarly, this is one thing that you should be aware of. Make use of live tasks during your work, and yeah, that's how a live script looks like. So you can finally save it. So within this live editor window, there is this export option where you can export it as a PDF, and you can export it. So let me export it in the desktop this time. Let me go to the desktop, and so here is the live task. So whatever programming you are doing, you can ultimately export it as a PDF file. Okay. So in other words, if you are giving students some kind of computational assignment, the students can not only verify it using the program, but also submit it after saving it as a PDF file as well. So instead of doing documentation separately using a documentation tool, that can be done very easily. So that is the idea here. Now going back to the Matlab window and clearing the screen. Let me show you another example using live script. So this is a example of mass spring damper. So where I am sure those who are from the mechanical engineering department are very much aware of this. So do we have, so how many of you are from mechanical department, or even if you have heard of this thing, mass spring damper, what is the function of a mass spring damper? You can just type a yes in the chat window. It will give me an idea of the, okay, I see 3 yeses as of now. Thank you. 4 yeses, 5 yeses from Arrow, heard in control system. Yes, yes. Okay, thank you. Okay, I see a lot of yeses. So yeah, so it is basically a system where we have a mass and we have a spring and we have a damper. So this is an external damper because we do not have ideal spring available. So spring will also have some kind of damping coefficient as well, which is represented by this damper. And we are applying some kind of external force to it also. So this kind of dynamic system can be represented by applying Newton's second law, where the sum of all forces will equals to mass into acceleration, where we use differential equations and represent as the acceleration vectors and define the different forces, one of which is external force, then is the force created by the spring constant and by the damper. So K and B are the coefficients, spring coefficients and damping coefficients, and we can finally come up with to this equation, a second order differential equation, which will define the motion of the system. Right. Now, if you want to solve this system in a analytically in Matlab, then how it can be done? So this is the first section, just to clear the screen, and I'm just running the second section, defining the constants here, like mass and the spring coefficient and the damping ratio, and defining the input force out here. So this is defined from using a slider, uh, which is just to define those aspects. Next, we try to solve the ODE. So for solving the ODE, we will need to know about symbolic mathematics. So we basically we define a very symbolic variable. So like if we want to solve a variable x, which is a function of time, then we write sims x of t. Then that becomes a symbolic function, and we can use the differentiation operation to differentiate on x and create the variable sims function dx. So these are the some functionalities that we can use in Matlab, and then the ODE equation can be written in this fashion. We are just writing the same equation which is written here, m x double dot plus c x dot plus kx equals to f equals to 0. The f comes to this side. Okay. And once this is done, we have to define the initial conditions or the boundary conditions, whichever it is. So the OD condition that t equal to 0, suppose we want the position to be 0 and we give initial velocity of 1. So we can just define it and store it in this condition variable. So after having these two things, the OD equation and the condition, we can use this dsolve. So this is another powerful function which will actually solve the ordinary differential equations and give you the result. So instead of you can, of course, you have for the courses where the student needs to solve it with pen and paper, they should do that, but they can compare the results using this computational tool as well and see whether they are getting those results after solving those ODs. And this is what the result looks like as of now. So let me see if I can create this damping ratio to 0. So there is no damping, and I'm giving a minimal force of 2. And here, let's run it. And let's run it. So now I'm not running it section wise. So the final section is to plot the solution with respect to time. That's it. So I can just run the entire program just to see the plot. And I want to see it side by side, maybe. Yeah, so this is how the this is the solution of the displacement versus time curve for the mass spring damper. Okay, yeah. So thank you. I see a question. Can we solve nonlinear differential equations? Yes, you can solve. And another question: how we are able to see the equation on the highlighting the OD? Okay, so yeah. So that's the so this equation. This is actually the output. So on the right, whatever you are seeing is the output. So this command is actually solving the OD and storing the output equation, and we are seeing the output equation here. So if we change some of the conditions, for example, instead of a damping force of 0, let me just increase the damping to 0.2 and rerun the program. So now we see we have a different solution because we have a different damping ratio. And because we have a different solution, obviously we will have a different plot because we are plotting the solution only, displacement versus time. So since we have increased the damping factor now, so after a certain time, the oscillation stops, which is the effect of this damping. So if we increase it to maybe the highest one that we have here, then it will be further damped. Now we only after one peak it is damped. We have no oscillation because of this damping ratio. So this is how you can slide different parameters and also teach this kind of concept whenever you are teaching this in your classes, theoretical classes. So maybe you can teach this live script, and we are happy to share this with you. You can modify it or create some live script on your own also, and you can use this to teach these simple concepts in the class itself. So this is a great way to do that. And now let me come back to the presentation slides. So what we learned, so we covered the first two demos. So we learned about this live script, and we learned about this mass spring damper demo, how we can use live script to show it in an interactive manner. So we also have a Matlab App Designer. So I would, with the interest of time, so I would like to highlight two things. So we can make app manually. This is one thing, or we can make app using the library, right? So let me quickly show you how you can make the apps manually. But that would take some time today. So let me just first open you to show you a manually created app. Yeah, for the same one. So this is a manually created app for the live for the mass spring damper, and and most of the things means to create this app, we are just dragging and dropping some of the blocks from the left side. Okay, and most of the code, so inside this code view, the code behind this app, whatever is grayed out is already written by the tool, and we only need to fill out the white portion to do certain functionalities. So once we know the code what we want to write in MATLAB, so we can create our own app, and we can finally show that app to the students. So for example, I just ran this particular app. So after running this app, a different window will appear, and here I can simply plot the response of the displacement and velocity. And similarly, this is the damping coefficient. I can maybe increase it, plot it again, increase it, plot it again. So just to see the effect means of the damping coefficient. So maybe if I give a higher coefficient, so how the plot changes with different damping coefficient or other values or mass or spring constant. So that can be also done interactively as an alternate of using LiveScript. Okay, and the good thing is that this app can be shared. Uh, it can be shared as a standalone desktop app as well as a web app, or it can be added in the app section in the library. Okay, yeah. So that's a good question. So where can you find this app? Yeah. So I just opened this app. So I didn't show you how to get started with it. So here in the app section, so that the first tab is the design app thing. So let me just clear up all the section. So if you click on design app, so this app designer will open up, and you can create new app. There are some example apps also which you can open up and get started with, some related to image processing, some related to animating flight status, some related to query data processing and those. But you can look into the examples, but you can also create a new app probably. And from here, you can start building your apps from these sections, right? So if I still, this is your canvas, nothing is created as of now. If I go to the code view, you can see. So this is the code for the canvas. So basically, you do not have to write too much code. Only thing is that when you are including certain things into it. So for example, let me uh, show you if I create. Okay, yeah. Let me show you one thing. So let me create, bring to edit numeric fields here, and another field maybe, and a push button. Okay, so maybe I'm writing this as variable a, variable b, and variable sum. Okay, so once I do this, I can just see the code view. So still nothing is created. So I have to basically create a callback. So if I want to calculate the sum of a and b whenever I press this button b. So let me just rename this button with sum. I want I want to calculate the sum of a and b. And how to do that? So I can create a callback function here. So it will redirect me to the code view page, and here I can define those variables. So suppose I want to write uh, I want to write I have to define the variable. So if I want to define a, then there is a way to define it. So if I have to just write a dot, these are the fields out here, like if you notice here, this is the variable a, then app.a edit field is the variable name. So if I write a, the edit field will appear automatically, and I have to just write dot value with a capital V. That's it. Similarly, if I want to define the variable b, then, and most of it is autofill. So whenever I write the first letter, I can just press tab to get the final value, and finally I can write a sum of A and B, and I have to store it in the sum variable. So which is app.sum edit field, which we can see here. So these are also mentioned in the properties section. If you see, sum edit field is one of the variables. So I have to just write app.sum edit field dot value. So I hope it is right. Sum edit field dot value equals to A cross B. Yeah, that's it. So I just defined AB, and I am passing the value of AB here. Let me go back to the design view and let me run this app. Before I run this app, it will ask me to save this app. So let me save this app as a app 123, and now here is the app. So let's see whether it is working or not. I am clicking on this sum button, and it seems to be there's some problem out here. Okay, so this is a line which is not required for the timing. Let me just edit it, and whoa, so what is the mistake here? Let me check 1 second. Okay, so yeah, so I let me just there is some mistake that I'm making right now. I'm not sure, so there is not much time now. Let me, with the interest of time, let me just open one of the app that I had created earlier, and let's find what's the error. So I'm just opening it just to show you. So this is a kind of calculator where we are calculating the sum. So if I am writing 10 plus 0, then sum should reflect here. Okay, so if I write 10 plus 20, it should be 30. So there has been something here maybe. But anyways, the point here is that you can make those apps and you can add it in the app section. And apart from that, we have quite a few existing apps which you can make use of for your teaching and research as well. So yeah, so let me then show you one existing app, which is the maybe the curve fitting app, and show you how you can do it. So we already defined a sine wave. Let's just plot a sine wave, or we can just make use of the command window right now. So suppose we want to define a sine wave using command window. Let's create a vector of length. Okay, and write y equals to sine of t. So we are just plotting this thing, and suppose I want to just see the I want to see the points, not the line version. I'm just including this. So these are the data points. Okay. So we can also maybe reduce this data point, the number of data points which are shown here. We can reduce it to 0.001 and define y. So this is the history bar. We can just make use of the commands which are typed in the past, and we can replot it. And so see, now we have finer points since we have reduced the data point. Similarly, suppose I want a crude data. I do not want so much points. So instead of 0.1 or 0.01, I am mentioning 1 and doing the same process again. So now if you see, now it is difficult to figure out whether it's a sine wave only if you go step by step and try to connect those points. Then you will get to know this is a sine wave. So suppose this is a kind of data we have and we want to fit this data using the curve fitting app. So this is the curve fitting app which I've opened up. So here you have to feed the x and y axis. So here in the x data field and y data field, we are providing the values and we have that these are the dotted values, dotted black values are loaded. And now we can, we have multiple options to choose from here to define the data points. So by default, the polynomial version is giving this kind of fit. Maybe we can increase the degree, but still it is not a good one. However, since we know already this is derived from a sine wave, so maybe we can try this Fourier option to just to see. Yeah. So choosing this Fourier is able to fit the data points using a sine wave, and the exact equation is shown here: a naught plus a1 cos omega x plus b1 sine omega x. But the parameters are also calculated from here. Similarly, we can maybe use the sum of sine wave also. There are other ways also to fit the same kind of plot. And once you are done with this, you will be able to see the curve fitted equation and you can generate the code out of this app. So this is true for all the apps. So whenever you do something in the app window, you can generate the code out of it and you can reuse the function. So inside the code, you can see the actual code which is used to fit that app. So these are the functions, fit type, fit options used, and finally this fit app to uh, fit the app and come up with the plot. So this is another thing. So there are two ways to do this app, and yeah. So maybe in the upcoming session, I will try to show you today the this app section with some other example, how to create a user defined app. Today there was some error and because of time I'm not trying to debug it as of now, but that I will share. But you should be aware of these two things. There are two ways you can make use of apps. Right. So now let's come to the resources to get started. So there are in this Matlab Academy website, there are multiple resources like Matlab on-ramp and many other on-ramps which you can see here. So if you are new, I would recommend you to start Matlab on-ramp, and you can do any other on-ramp as well to get started with those specific domain subjects. You also have access to advanced courses which are longer ones like MATLAB fundamentals and others mentioned here, which are 14 hours courses. It is also self-paced one, so you can do it at your own pace and for better understanding of these subjects also. Some are related to mathematics domain like ODE and solving nonlinear equation and linear algebra, which would be very useful for you. So this is available. Also, there is another page which is known as the courseware page. So for all the faculty members, uh, if you visit this page, you will be able to figure out the appropriate links related to your subject, and you can find multiple resources in the form of lecture notes and existing shared codes and project ideas, which you can make use of for your subjects. There is also this courseware page for science, specifically dedicated to the science subjects like physics, geoscience, biology, and mathematics, which is in the first row, as well as in the other science related topics. So you can go through this link and you can explore the resources out here as well. So these are some pages where you can find those resources very easily. And finally, so okay, just for checking, so we are slightly over time. So is it okay if I can extend this for till 4:45? Because there are some more things that I would like to just mention.
Yes, sir. Yes, sir. You can.
Sure, thank you, sir. So I would be discussing about the student engagement aspect. So how can you engage the students? So now the students will be engaged in those courses. So when they do certain aspects computationally, okay, so they may make mistakes. So for example, while making the app designer today, so there was some kind of error. So to do debug that error, that may be a small error, but to debug it, it may take some time. And after debugging it, the student will be able to enjoy it. So that the comic that you see here in the left, in the right corner, so I swear it was working a second ago. The student made some kind of project, and when the examiner comes, the project is not running. So this kind of situation happens quite often. So we do not need to worry. So we always learn from our mistakes. So only when we are trying more or doing more, then we will make more mistakes, and finally we will be improving ourselves. So that is how we want to engage our students with. And one of the ways is project-based learning with hardware. So when we are including maths plus the computational tools, there is another aspect of hardware. So whenever there is opportunity for student-based projects, so for example, in tech fair, student competitions, and actually when the students are doing some projects related to hardware, they can also make use of the hardware, which most of the low-cost hardware like Arduino, Raspberry Pi, those are supported by our tool as well. So we can let you know the appropriate resources for that as well. So as a user story, just an example for a first year engineering course at KLE Tech. So they have made a line follower robot where you can see uh, the robot is moving along this line, black colored line. So they were able to make this kind of robot using Matlab and Simulink with the model-based design approach. So here you can see it is not visible very much, but yeah. So this is a part of Simulink known as state flow, where we can model different states. So using a state flow diagram, they have modeled this line follower robot. Okay, tested in the breadboard, and finally they have deployed in the curriculum. So this is how you can. It's a great way to engage students right from the first year. So more than 1,200 students are offered that engineering exploration course, and they were able to focus on the problem by solving over coding. Okay, and finally with this experiential learning. So here also means for the first year courses, where computational courses, wherever you are having those kind of computational uh, labs or assignments or classes, you can incorporate this hardware component as well gradually with time. So that can be an addition to it for nice experience. So apart from Arduino, there is this Matlab Mobile as well, and yeah, Matlab Mobile and other hardwares are also supported. So, so this is Simulink, which is I don't know why slide is moving by itself. Yeah, so this is the Simulink window where we can use those kind of. So this is some bit advanced stuff for now. So we would be covering Simulink in the 5th week. We will revisit it. Similarly, for IoT related applications, we have ThinkSpeak, which we can connect, and we have this Matlab Mobile. So let me just give you a brief look of Matlab Mobile, how you can get started immediately. So you can directly install Matlab Mobile from your App Store and open it. So here there are some pre-existing examples. Okay. So even before writing anything, you can just start using some of the examples. So one of the example is to learn calculus using Symbolic Math Toolbox, where the example is written in the form of live script, and the student can read it, understand what are the different computation, how we are integrating or differentiating the functions, and by running it, we can run it in the mobile itself, right? And we can see the solution. So after running, we can view the plots. So the different plots which are used in the program can be viewed also in the mobile itself. So this is one way to use Matlab Mobile in the curriculum as well. Secondly, for project also, so every mobile will have some kind of sensor. So either it will be those accelerometer or gyroscope things. So yeah, which will calculate the acceleration, magnetic field, orientation, and other things. So these are calculated in real time. So this data can be logged. Okay, this data can be logged, and certain exciting projects like human activity recognition can be done using Matlab Mobile as well. So yeah, so this is about Matlab Mobile. I see one question related to Grader and Simulink can be done in mobile version. So no, the answer is no to both of them. So as of now, uh, you cannot do the Grader as well as Simulink in mobile version. So that is not possible. So let's see if later it happens. It can happen at a later stage, but as of now, you can use some of the basic features of Matlab. Yeah, and this is Matlab Online. So if you want to get started, you can just click in this link. So these links are provided in the slides. So I would be sharing this, so you can just get started with this. And another important about automatically grading the Matlab code is Matlab Grader. So we will cover this in more details in week 3. So here we will show how we can use Matlab Grader, which can be used through the browser itself. So you will need a browser for it. You cannot do it directly from the mobile. And how we can do the workflow. So this is from the assessment part. So to summarize it, we need to understand 3 things. So we need to make use of the computational tools for problem solving. So we have this live editor and Matlab apps to do that. Now we have to, the challenge is to engage the students in classroom. So how can we do that? So we can offer them Matlab online courses, maybe some of the on-ramp courses as a part of the assignment, the basic courses or the domain specific courses as a part of assignment for the curriculum. And they can show the certificate when it is done. They can also do project based learning. So once the students are involved using hardware for their projects or for their different courses, they can involve, you may involve that also in the curriculum or in the project work. So that will increase the student engagement. And finally, to assess the students. So how we can assess the students? So we can use these the tool Matlab Grader here. This is one way. Uh, to give assignment and automatically grade them, which will save both the instructor's time as well, and also the student will get the feedback at an early stage. Now, we also have Simulink, which is the second icon is for the Simulink for model-based design. So we will get into it in more detail in week 5, how to get started with Simulink environment and cover some of the Simulink related examples. And now coming to another user story. So this is from Manipal Institute of Technology, where they have integrated Matlab and Simulink both into their engineering curriculum. So here, what was the challenge? The challenge was to produce graduates who are ready to meet the demands of industry and academic research by integrating hands-on learning with the classroom teaching. So that is the basic challenge that we need to address in different places. So what is the solution that is listed here, that is said here? So by acquiring campus-wide license, the college implemented first-year course on problem solving using computers and introduced students to the principles of programming in Matlab and C. So an elective Matlab for engineers introduces the concept of code generation and simulation of mechanical electrical systems in Simulink. So there are two things that this is how they have addressed. They have used both Matlab and Simulink starting from the first year itself. So this resulted in better learning curve for the students. And let's read this quote from Dr. Vinod Thomas from the institute. So we are fortunate to have the autonomy to define a curriculum that enables us to best prepare our students and differentiate our university from other schools. And to help us meet those goals, we have integrated Matlab Simulink into the engineering curriculum starting in the first year. So that is from this user story. So you also have campus-wide license, so you can also, and already I already know that you have already started in the first year courses, but similarly we can enhance it and we can work together to make it better also. Now, very briefly, giving a recap of the 5 things that you should remember about Matlab. So this is the Matlab window, which has an interactive desktop where we have a current folder tab where we can see the type of files and the files stored. We have the workspace variable where we can store the data, we can visualize the data. And this is the main tab window where we have different options to select from. Under plots, we have different kinds of plots which we can plot. Under the app section, there are multiple apps, out of which we saw the curve fitting app. And so this is a different app, a classification learner app, more focused on AI related application, and how we can generate code from any of the apps. So out of all the apps, you can at the end export the model or export the code, which will be in the form of MATLAB script. Third, we learned about live editor. So we learned about live editor, how we can use live editor live tasks to study certain simple concepts. So similarly, fourth is the function library and the help browser. So this I didn't mention here. So there is this help browser right here. So let me just run this video. So in this help section, if you click here, then it will redirect you to the documentation page where you can explore different features of MATLAB as well as Simulink by clicking on the links. That is one way. Second, you can type out the particular thing that you want to do, you're searching for in the help window. Like you want to find roots of a function, just type it in the help bar and we have a very rich set of documentation. Then based on the search result, you can see which one to choose. And you will more often than not, you will get to another page with a similar example and the different functions that are used. Within the function, you can see what is the function, what is the syntax of the function, how it is used. You can read the description. You will also have some examples. Similarly, if you want to search for something else like how to do a ODE, how to solve a ODE, you can type that in within the first link. You will see the different ODE solvers that are available. You can get into the details of those ODE solver like ODE45, how to use it, how to use this solver to solve differential equation. So there are examples to get you started with any topic. So you do not have to spend a lot of time searching. And in case you are not finding anything that you want, that you are searching, you can always write a mail to us. You can get in touch with us. We will be happy to help you along those lines. So this is another thing about the help browser and documentation page. And finally, the on-ramp, the Matlab Academy website, where you have these self-paced courses available. Okay, so this is the documentation page. We have tutorials, and these are the things. And this is the courseware page. I think some of the slides is repeated. So yeah, so don't worry. Okay, so most of the things are covered for today. Another thing that I wanted to let you know about this research and design project uh, uh, idea for students. So if the students in the final year, so they can also visit this Mathworks Excellence in Innovation Projects page. So there is a GitHub page for this, where if the students are working in fields related to this 5G, AI, autonomous vehicles, computer vision, neuroscience, robotics, drones, etc. So they can just click on those links and they will find multiple problem statements. So if they are interested in those projects, they can also read those statements and get started with that. They can uh, maybe and submit the solution in the that page also. So that will be a good starting point for the final year students who are doing their capstone or project work for students. So this is in the final link. Yeah. And these are the courseware pages which I discussed earlier. Uh, yeah, so this is, so sorry for being overtime today, but this gives the overall idea of all the or almost most of the features of modern MATLAB. So I would be sharing this, and I would also request you to do a post activity session to, so those who are new, or even if you are existing user, you can complete the Matlab on ramp from Matlab Academy. So that is in the Matlab Academy website. So let me just show you how it looks like. Okay, let me bring it here. I'm just typing Matlab Academy, and yeah, so this first one, so the first course, so you can view the progress. You can share the certificate and view the progress when you are doing the course. So I'm just running the course for the time being. So this will give you the course overview, and uh, in the Friday session which will be taken, so some of the uh, basic fundamental features of MATLAB will be covered continued. So before second week, that is before Tuesday, you can start today itself. It's a 2-hour course. You may complete it before Friday as well if you are able to, if you get time. Otherwise, before the next week, if you can complete this MATLAB on ramp. Okay. So I would be sharing this link with you. I hope this is, actually I'm already signed in, so I'm just seeing whether it works okay outside this. Okay, one second. Matlab Academy. Yeah. why it is taking so much time to open. It's taking too much time to open. I don't know why. Anyways, I will let me share this main link itself here. So from here you can do the first one as a post requisite, which will be good for all of you to get started who are new, as well as those who know they can revise it. And those of you who are extensive users, some of who are using it for a long time, they may not require this course, so they may do the other course inside this core Matlab function, Matlab fundamentals. So this is a longer version of the course, which has a deeper dive into different aspects of Matlab. So you may do this. Okay. So this is a thing, and let me finally share you a feedback link. So one feedback is that we have gone over time, so that I will try to rectify further. Uh, but apart from that, whatever your comments and thoughts throughout the session, you can fill it in the chat window. I'm just posting it right now. Yeah. So let me see if it is okay. Yeah. So this is the feedback forms. You can just fill it, and also give your comments. We will try to improve, and we will read through it. So okay, yeah. So this for a kind of interactive session from the chat. I see a lot of comments. So one is extend the duration for the session. So we purposely if we extend the duration, it won't be that effective actually. That's why because in online mode, the concentration level falls at a later stage. So that is one thing. Another, we have some bandwidth issue also. Uh, so that is why we want to keep it today. Today's session was the first one, so it got extended. But we will try to cover what we intend to cover in most of the session, and so that we can have an interactive and good learning experience over the all the weeks. So that is our main intention, that we will try to do. Any management department tools? Yeah, so there are. In fact, there are IIMs for some of the IIMs also use our tools. So they use, there are tools related to finance application as well. You can fill, write these things also, you can mention in the comment section. We will try to get back to you. We will share you the relevant links, and you can best is you can, if you can drop a mail to us, yeah, because there will be lot of response, I guess. So if you can drop your specific query to us, anything related to technical of your curriculum or research, any of us, we can get back to you. And if you have query related to licensing also, you can write to the support team, or you can mention to us, we can direct you to them. Instead, if you are not able to install Matlab due to some kind of technical issue, so that, okay, where you can write the feedback. So I shared this link. I am sharing it again. So there is this tiny URL form, so which you can fill it here. Feedback link is not available. So is there a problem with the feedback link? I am not sure. So I'm just showing it in the. Okay, I see. No. Okay, it's working. Okay, thank you for the response. So some of the faculty members have already given filled a separate form, which has some of the points related to which I mentioned here as well. So apart from that, everyone else can also fill, and best is you if you can just mail us. If you can write a mail to any one of us, and we will try to get back, respond to it. So I'm stop sharing the screen. Uh, oh yeah, so Shovik is also there. So I just saw now. Thank you. And yeah, so he's that is better to use the latest version since you have the facility to use the latest version. So now you can use 2021A, or in a couple of weeks maybe you will have the access to the B version also. So for the time being you can install it, and thank you. So if you have, so I suppose it is 4:57, we can stay till 5. So if you have any questions, you can unmute yourself and ask also, apart from the things you are mentioning in the chat. So I'm very thankful. There are a lot of questions and comments in the chat window. Thank you.
Anand sir, do you have any other slides to show?
No, means slides are okay, over for today. So
Okay, sir. I take this opportunity to thank the management in the Sun Institute of Technology and Science, Chancellor Dr. Elizabeth Verghese, Pro-Chancellor Dr. Anand Verghese, Director Ashok Verghese, and Vice Chancellor Sridhara for allowing us to conduct this program to enrich the knowledge of the faculty members. And I would like to thank our Dean ENT, Dr. Vasudevan, and IQAC Coordinator, Dr. Sudhu, and especially our HOD, Dr. Ramesh Babu, for encouraging us to conduct this program. I also take the opportunity to thank Mr. Rapper, Harish, Mr. Anand, and Mr. Janathan for accepting our invitation for this program. I extend a warm thanks to all the participants, faculty members, research scholars from different departments. Thank you, one and all. Thank you, sir.
thank you, Professor Simon, and thank you everyone for attending today's session and asking so many questions and comments. Thank you. So we will look forward to the next one, Friday. And before that,
Yeah.
if you can complete the on-ramp, at least you can start the Matlab on-ramp. And by the start of next week, you can complete it. It will be very good.
Yes, sir. Yes.
Yeah.
On Friday at 3 p.m., we can start 10 or 15 minutes before so that others can join comfortably.
Yeah, we will join 10 minutes before, and let the timing remain the same, means 3 to 4:30, and
Yeah.
we will, yeah.
And if possible, can you add the gap that you left today? How to create the app in Matlab?
Right. So that I will surely show in the upcoming session. So we have other session also. So how to create an app from scratch. So with another example, we will surely showcase it.
Yes, sir, yes.
Yeah.
And do you have a tutorial for partial differential equations? You have mentioned ordinary differential equation many things, but when I was trying for a partial differential equation, I could not able to find a suitable tutorial, which is a very important topic in the third semester. Are you going to add in the third week? Who is going to handle the third week session?
So third week session we will be handling it. So yeah, so we will be covering. I've taken a note of it. So we will be covering some examples of partial differential equation then in one of the sessions. And yeah, very rightly said. So there are very few videos related to it. So some of the examples that are already there, so we have shared earlier, but let's see if we can have more. We will let you know. Yeah.
Yeah, because of this July to November, we'll be dealing with partial differential equation and its application to string problem, rod problem, plane problem. So these are the important topics where our faculty need to be trained to in order to train the students in the third semester mathematics. In the fourth semester, I told you already about the numerical method. So we don't have enough program, Matlab program to solve the differential equation numerically. Anyway, that part is coming under the November to March session. But for this July to November, we need your training on partial differential equation and its applications. And the third, fourth, and fifth unit, we focus on Fourier transform, Fourier difference equation solution using Z transform. So these are the main key area to be covered in the third week and their corresponding application, engineering application, how the Matlab can be used to teach this mathematics. Priyan.
Okay, sure, sir. Yeah. So I got the point. So we will frame it accordingly. Yeah. So that PD as well as numerical, those things are covered in the third week. Right.
Yes. Yes, sir. Thank you so much.
Yeah.
What about the Janardhan sir and Harry sir there? Still they are in the meeting?
Janardhan, are you there?
Yes, yes, yes. Hello, hello, sir.
Uh,
Sorry, I
yes,
lost. Yes, I'm in, sir.
yes, sir. This is regarding the manual preparation. As I told you, I have shared my prepared PDF file with you,
Yes,
and the textbook, Advanced Engineering Mathematics using Matlab. And from your side, what are the study materials that we can share with us so that we can ask our faculty to prepare the manual? And our VC has instructed to include Matlab wherever possible in all the
okay,
curriculums.
okay. Fair enough, sir. I will just cross-check along with Jafar, with whom you spoke a couple of days back. Okay, I will just take his inputs and I will respond back to you accordingly, sir.
Yes, sir. Yes, sir. Thank you so much, sir.
Thank you so much.
See you on Friday at
Yes, absolutely, sir.
4:45 p.m.
Yes, sir.
Have a nice evening, sir. Bye.
Yeah, thank you, thank you.
Thank you,
Bye,
sir.
sir.
Thank
Bye.
you, everyone.
And
Bye.
kindly share the video recording for official purpose. We need to keep it keep it for future reference. So kindly do the needful, sir.
Sure, sir. I will share it. Yeah.
Thank you so much.
Yeah. Thank you. Bye, everyone.
Bye. Sir.